And I'd like to thank the government for the support in getting the approvals and making progress, as you can see. We're looking forward to hopefully getting the approval to make the first cars maybe in October if we're fortunate.
What is the future of cars? Hydrogen or
definitely electric.
Yeah,
Hydrogen is a waste of time.
But
obviously.
einen Wissenschaftsstreit.
No one saw it coming. In a world where Tesla has long been the face of battery-powered mobility, Elon Musk took to X and dropped a bombshell. Tesla is pivoting, away from lithium-ion dominance and towards something even bolder. The next chapter in clean transportation, he claims, will be powered not by batteries or gas, but by water. The announcement set the tech world ablaze. The water engine, Musk tweeted alongside a sleek video of a concept vehicle releasing only vapor from its tailpipe. The implications are massive. Tesla, once the champion of battery innovation, is now betting big on hydrogen, and by extension, water, as the cornerstone of its future mobility strategy. The shift comes in the wake of persistent challenges with Tesla's 4680 battery production, delays that have slowed new model rollouts and hampered supply chains. Instead of doubling down, Musk did what he's famous for, pivoting with audacity. If batteries are reaching their technological ceiling, maybe the next leap isn't more lithium, it's less of it altogether. And now the question echoing across garages, boardrooms, and kitchen tables is simple but seismic. Can water really power your next car? The world has long hoped for a truly clean, sustainable engine, one that leaves behind no trail of carbon, no toxic footprint, and no geopolitical dependency. Elon Musk just claimed to have found it. But as the hype builds, so does the pressure. The next big question isn't just whether the technology works, it's whether Tesla can make it real. And to understand why Musk is risking so much on this shift, we have to go back to the root of his mission. Elon Musk's lifelong obsession with sustainability. Elon Musk has never been in it for the cars. Not really. From the very beginning, his mission has been about something much bigger. Sustainability, survival, and reimagining how civilization powers itself. When Tesla launched in 2003, skeptics called it a vanity project. Now it's a juggernaut. But Musk never saw it as just a company. He saw it as a catalyst. This obsession with a cleaner planet has threaded through every venture Musk touches. At SpaceX, it's reusable rockets reducing waste and revolutionizing aerospace. At Solar City, it was solar panels for homes, democratizing clean energy. And at Tesla, it's been about electrifying the road. One car, one charging station, one breakthrough at a time. But batteries, for all their power, come with their own environmental burdens. Mining, rare earths, degradation. Musk knows this. And with Tesla's battery scale-up hitting logistical and material roadblocks, his gaze shifted. If the ultimate goal is clean energy at planetary scale, maybe the solution isn't in the earth, but in the water. That's what makes Tesla's water engine announcement feel like more than a publicity stunt. It feels like a return to the original promise, bold technology in service of a better world, clean mobility that doesn't trade one form of pollution for another. It also explains why Musk is willing to challenge his own past beliefs. Years ago, he dismissed hydrogen tech. Today, he's betting Tesla's future on it. Why? Because the mission hasn't changed, but the tools to achieve it just might have. So what exactly is a water engine, and how does it even work? What is a water engine, really? At first, it sounds like science fiction. A car that runs on water? But what Musk unveiled is rooted in decades of scientific exploration and may finally be mature enough to change the game. The water engine is essentially a hydrogen-powered system built around reverse electrolysis. In simple terms, water in, electricity out, vapor as the only emission. Here's how it works. Water, when split into its elements, hydrogen and oxygen, becomes a source of energy. That hydrogen is fed into a fuel cell, where it reacts with oxygen pulled from the air. The chemical reaction generates electricity to power the motor, while the only byproduct is water vapor. No smoke, no carbon, no poison in the skies. This isn't just a cleaner engine. It's potentially the cleanest propulsion system humanity has ever seen. No gasoline, no tailpipe toxins, and none of the long-term waste issues that plague battery manufacturing and disposal. It's energy, looped. Water becomes power, power becomes motion. And then, back to water again. Musk is presenting this not just as an alternative, but as a leap forward. A future where cars are emissions-free without the dependency on rare materials. A system that works in harmony with the environment, not against it. Of course, a concept this ambitious invites scrutiny. Can it scale? Can it compete? And perhaps, most importantly, how does it stack up against the technologies we already have? To answer that, we have to see how water engines perform in the ultimate showdown, gas versus electric versus hydrogen. How it works, the magic inside the machine. There's a quiet elegance to it, a system that transforms something as abundant as water into clean, usable energy, and then leaves nothing behind but vapor. The water engine isn't magic, but it might be the closest thing we've seen to it on the road. At its core, the technology works by splitting water molecules, H2O, into hydrogen and oxygen through reverse electrolysis. That hydrogen is stored on board in a compressed, high-pressure tank designed for safety and efficiency. When the car is running, the hydrogen flows into a fuel cell where it meets oxygen from the air in a chemical reaction that produces electricity. What powers the motor are the freed electrons. Meanwhile, the hydrogen protons bond with oxygen to form, once again, water vapor released gently into the atmosphere. There are no explosions, no smoke, no carbon trails. It's a quiet, contained miracle of chemistry, and it all happens within seconds beneath the hood. Tesla's engineers have designed this closed-loop system with the company's signature obsession for integration. The storage, flow, and conversion are all optimized for speed and range. No long waits to charge, no thermal runaway, just refuel and go. The beauty lies in its simplicity and its sustainability. The same water molecule that begins the journey ends it, reborn in the atmosphere without harm. It's this full-circle energy logic that makes the water engine not just efficient, but poetic. Still, poetry alone won't win the race. How does this revolutionary system stack up against what's already dominating our highways? Water versus batteries versus kitosis. The power face-off. If this is a battle for the future of transportation, then let's meet the contenders. Gasoline engines, the reigning champion of the 20th century, offer power, but at a massive environmental cost. EVs, the electric titans of today, are cleaner, more efficient, but face issues with charging times, battery materials, and infrastructure. And now, water engines step onto the stage, carrying the promise of speed, sustainability, and simplicity. Gas engines average about 20–30% efficiency. The rest of the energy, lost as heat, noise, and pollution. Add in the 4.6 tons of CO2 the average gas car emits each year, and the case for their retirement becomes clearer by the day. Electric vehicles brought a revolution. With up to 90% energy efficiency, smooth acceleration, and no tailpipe emissions, they reshaped what a car could be. But lithium mining, battery disposal, and slow charge times cast shadows on their green image. Water engines, or more precisely, hydrogen fuel cell systems, land in the middle on efficiency, clocking in around 60%. But they refuel in minutes. They don't rely on rare earth materials. And their only emission is vapor. No smoke, no carbon, no combustion. It's a quieter, cleaner solution, perhaps not the most efficient, but arguably the most sustainable. This isn't just about numbers. It's about what kind of world we want to drive through. One choked by fossil fuels, one tangled in lithium geopolitics, or one powered by something as universal as water. For Elon Musk, the answer is clear. He's not chasing maximum efficiency, he's chasing maximum impact. And if that means turning away from batteries and toward the world's most abundant resource, so be it. Coming up next, why this might be the engine that could save the planet. Why this engine could save the planet. We talk about climate change in terms of decades, tipping points, and carbon caps, but sometimes the future turns on a single invention. If Tesla's water engine lives up to the promise, it could be one of those moments. A true zero-emission vehicle that bypasses the compromises of both gas and electric, offering clean energy without the baggage of combustion or rare mineral dependency. Consider the baseline. The average gas-powered car releases roughly 4.6 tons of carbon dioxide every year. Multiply that by hundreds of millions of vehicles, and the result is a planetary crisis that worsens with every ignition. Even electric vehicles, though vastly cleaner, still come with upstream emissions from electricity generation and resource extraction. Batteries degrade, supply chains sprawl. The process, though better, isn't perfect. Now imagine a car that emits nothing but water vapor, no nitrogen oxides, no smog-forming particulates, no invisible clouds of carbon, just clean movement, with water completing a perfect chemical loop, split, converted, and returned. And because hydrogen can be produced from renewable energy sources like solar and wind, the water engine doesn't just solve emissions, it supports an entire green energy ecosystem. The biggest bonus? It avoids the geopolitical and environmental toll of lithium and cobalt mining, industries fraught with ethical and ecological concerns. A world of water-powered cars means a world less dependent on extractive practices and more focused on sustainable innovation. Musk knows that no single technology saves the planet, but with this engine, he may have found a way to bypass the biggest bottlenecks in clean transportation. The question isn't just whether it works, it's whether Tesla has engineered it well enough to scale. And that brings us to the nuts and bolts, the breakthrough that could make it all possible. Tesla's engineering breakthrough. For all the bold claims and dazzling ideas, Tesla's magic has always been in the engineering. It's not enough to dream. Musk demands that dreams be built, tested, and driven. With the water engine, that mandate remains unchanged. And now, behind the scenes, Tesla's engineers are unveiling what may be the most critical innovation yet: reverse electrolysis systems that work cleanly, safely, and on demand. It starts with producing hydrogen from water without relying on external suppliers. Tesla's system uses renewable energy to split water molecules at the point of use, producing fresh, ultra-pure hydrogen when needed. No long-haul transportation, no dependency on fossil fuel-based hydrogen production. It's clean from source to wheel. Then there's the matter of storage. Hydrogen is notoriously tricky. It's light, explosive, and hard to compress. But Tesla's new high-pressure storage tanks are compact, crash-tested, and reinforced with next-gen materials designed to contain and protect under all conditions. This isn't theoretical safety. It's real-world, Elon-style over-engineering built for highways, collisions, and daily life. And the motor system? Minimalist, fewer parts, fewer breakdowns, and virtually no routine maintenance. Unlike combustion engines with hundreds of moving components or batteries that degrade over time, fuel cells offer durability and consistency, fewer oil changes, fewer trips to the mechanic, lower lifetime cost of ownership. It's the kind of engineering that turns vision into value, that transforms wild-sounding ideas into daily commutes. And just like Tesla did with EVs a decade ago, it's poised to force the entire auto industry to catch up. Again. Still, breakthrough tech doesn't mean much if people can't afford it, which is why the next step in this story is perhaps the most important one of all: the cost factor. Is it affordable for the masses? For most drivers, it all comes down to one thing: can I afford it? And for all the brilliance behind the water engine, its impact will hinge not just on innovation, but on accessibility. Musk knows this. He's been here before. From the Roadster to the Model 3, Tesla's journey has always been about driving down costs through scale. And this time, the challenge is even steeper. Right now, hydrogen fuel cell systems aren't cheap. The components are specialized, the infrastructure is limited, and early production costs are high. But here's the Tesla difference. They don't just build cars, they build factories, supply chains, and economies of scale. If anyone can bring hydrogen to the masses, it's the company that made electric sexy and profitable at the same time. The key advantage lies in maintenance. Water engines, like EVs, require far less service than gas vehicles. No oil changes, fewer moving parts. And with fuel cells projected to last hundreds of thousands of miles, drivers could see real savings over time, especially as fuel costs drop and tech matures. Tesla's vertical integration strategy also helps. By controlling everything from component production to software updates, they reduce reliance on third-party markups. That makes the dream of a sub-$30,000 water-powered Tesla not just a fantasy, but a near-future possibility. The curve will be steep, but Musk has never been afraid of curves. And if he can get the cost right, everything changes, not just for Tesla, but for the clean transportation as a whole. Still, there's one more hurdle. Even the cleanest, cheapest engine can't move without a place to refuel. And right now, that place is hard to find. The infrastructure problem. Where will you refuel? The engine might be revolutionary. The performance might be flawless. But without a place to refuel, even the most advanced water-powered car becomes a driveway decoration. And this is where hydrogen still faces its most pressing obstacle: infrastructure. Today, hydrogen refueling stations are few and far between. In the US, they're mostly clustered in California. Japan has made progress, and parts of Europe are expanding fast. But the global network is nowhere near what EVs have with charging stations. It's the Achilles' heel of hydrogen adoption, and Musk knows it. That's why Tesla isn't stopping at the vehicle. They're planning to retrofit select supercharger stations to handle hydrogen, creating dual capability hubs across high-traffic corridors. It's a bold move and a necessary one, because without places to refuel, even the best tech stays stuck in neutral. Partnerships will be critical. Tesla is reportedly in talks with governments, energy providers, and private landowners to accelerate the rollout. Just like SpaceX partnered with NASA, Tesla may team up with public agencies to build a coast-to-coast hydrogen backbone. But it's a race against time. For the water engine to catch on, infrastructure needs to lead the way, or at least keep pace. And that means education too. Cities, states, and consumers will need to understand how hydrogen fits safely and effectively into everyday life. Still, infrastructure can be built. And if Musk has proven anything, it's that what seems impossible on Monday can be halfway to reality by Friday. Which brings us to a crucial and very real concern. Is it safe? Safety first. Is hydrogen too risky? Hydrogen's history carries baggage. From the Hindenburg to Hollywood explosions, public perception is filled with fiery cautionary tales. So when Tesla announces a hydrogen-powered engine, the first question isn't about efficiency, it's about safety. Is this really something we can trust? Musk, ever aware of optics, tackled this head-on. Tesla's hydrogen tanks are engineered with the same rigor as its rocket fuel systems, sealed, reinforced, and designed to survive high-speed collisions without rupture. Sensors monitor pressure, detect leaks instantly, and trigger automatic shut-off protocols. It's not just a car system, it's aerospace-grade safety applied to ground travel. And there's a counterpoint worth remembering. Gasoline is also highly flammable, so are lithium-ion batteries. But we've learned to live with them because we trust the systems built around them. The same is now happening with hydrogen. Proper storage, smart engineering, and rigorous testing can turn perceived danger into proven dependability. Tesla isn't just building the tech, they're preparing a campaign of transparency. Public education, independent certifications, and demonstrations are in the works to show consumers how hydrogen behaves, how it's stored, and why it's safer than most assume. Because winning trust is just as important as winning market share. Yes, hydrogen requires care, but so does every energy transition. What matters is whether the systems supporting it are built to the highest standard, and whether the public feels informed, not intimidated. The foundation is being laid, and with safety protocols in place, all eyes now turn to the wider response, what the experts are saying. When Elon Musk speaks, the world listens, but when he pivots, the world splits. Tesla's hydrogen-based water engine announcement has sent shockwaves through the scientific, automotive, and energy sectors. And now the experts are weighing in with a mix of admiration, skepticism, and recalibration. Toyota, long a proponent of hydrogen technology, publicly welcomed the move. They called it validation, a nod to the fact that they were mocked for championing fuel cells years ago. For them, Musk's shift feels like vindication. If the loudest battery evangelist is now exploring hydrogen, the debate is far from over. Not everyone is applauding. Some Department of Energy officials warn that infrastructure costs remain daunting and could outpace even Tesla's rollout ambitions. At the Paris Olympics, over 100 scientists signed a joint letter criticizing hydrogen vehicles as inefficient and impractical for mass use. But those critiques were built around older models, not reverse electrolysis with on-demand hydrogen production, something Tesla now claims to have solved. In classic Musk fashion, the move challenges not just competitors, but industry orthodoxy. Critics say it's too soon. Musk says it's already too late to keep waiting. And somewhere in the middle, innovation is pushing forward. As the experts debate logistics and viability, one thing becomes clear. This isn't just a trend, it's a turning point. Whether they're skeptical or supportive, thought leaders everywhere are now forced to consider what they previously dismissed. And while the institutions wrestle with implications, the most honest reactions often come from a different group, the people. The public reacts: hope, hype, and hesitation. The moment Musk posted the teaser video for Tesla's water engine, the internet lit up. In a matter of hours, hashtags trended, headlines stacked, and comment sections exploded with emotion. For many Tesla fans, it was pure elation. After years of emissions talk, climate urgency, and battlefield debates, here was a solution that felt like science fiction come to life. People praised the simplicity. Just water? That's it? Others called it the end of gas. Even more saw it as Tesla's return to bold form, less about stock charts, more about reshaping the world. Hope surged across forums, especially among young climate activists who've grown cynical about half measures. For them, this wasn't just innovation, it was redemption. But not all responses were celebratory. Some remembered Musk's previous comments dismissing hydrogen tech, calling it fool cells. The reversal stirred confusion. Was this another pivot or a real commitment? Others, still waiting on Cybertrucks and full autonomy, worried this could be another promise ahead of its time. There's also a deeper skepticism. People want to believe, but they've been burned before, by vaporware, by hype cycles, by launches that never landed. And the question echoed, if this is so revolutionary, why now? Still, curiosity remains stronger than doubt. Even skeptics admit the idea is compelling. And unlike other concept cars or clean technologies buried in white papers, this one came with a name, a platform, and Elon Musk at the center. That alone guarantees attention and pressure. What matters now is whether Tesla can deliver not just on vision, but on scale. And if they do, the implications go far beyond cars. Global implications: energy, geopolitics, and jobs. A car powered by water may sound like a technological shift, but it's also a geopolitical earthquake. If Tesla's hydrogen engine gains traction, it could shake the foundations of global energy, redraw alliances, and birth entire industries seemingly overnight. Oil dependency has shaped wars, foreign policy, and entire economies for over a century. A pivot away from gasoline vehicles toward engines that run on hydrogen produced from local water and renewable energy could unshackle nations from volatile fuel markets. Energy independence would no longer be a dream of oil-producing giants, but a possibility for any country with sun, wind, and water. For governments, the implications are massive. Hydrogen production, fuel cell maintenance, infrastructure deployment. These open up job markets not just in Silicon Valley, but in small towns, factories, and tech corridors worldwide. The promise isn't just cleaner air, it's better paying jobs, decentralized energy, and a new industrial era built on sustainability. Tesla, in this context, stops being just a car company. It becomes a cornerstone of the clean energy economy. A disruptor of oil, yes, but also of battery mining empires, combustion engine suppliers, and even electric utilities. Musk has always said Tesla's mission was bigger than vehicles. With the water engine, that mission steps onto a global stage, forcing industries, governments, and citizens to confront a future where mobility is no longer tethered to carbon, conflict, or compromise. And just as that future comes into view, the question becomes, where else could this go? Beyond cars, the future of water engine technology. If a car can run on water, why stop there? That's the question now echoing through R&D labs and corporate boardrooms. Because while Tesla's immediate focus is transportation, the potential reach of hydrogen-powered technology stretches far beyond the road and into the very systems that power our modern world. Imagine cargo ships that no longer burn bunker fuel, but glide across oceans powered by clean hydrogen. Picture aircraft emitting only vapor as they soar through the sky. Envision remote power generators running on water, not diesel, bringing energy to villages, construction zones, and military bases without the logistical nightmares of fuel delivery. For Musk, this isn't speculation, it's strategy. Tesla's expertise in energy storage, propulsion, and system design gives it a unique edge to scale hydrogen beyond cars. They already build home batteries, solar panels, and grid-level storage. Now they're quietly developing modular hydrogen fuel units, that could power everything from data centers to electric planes. And in an era defined by energy transition, those units aren't just technical marvels, they're tools of transformation. Industries with no viable decarbonization pathway could suddenly find a way forward. Entire regions lacking stable grids could leapfrog straight to clean hydrogen microgrids. It's a ripple effect, where the success of one engine sparks the reinvention of many sectors. The water engine begins a mobility revolution, but it could end as a systems revolution. Which leads us to the biggest question of all: is this the technology that will define the future? Will water engines redefine the future? The answer, like the engine itself, is still forming. On one hand, Tesla's announcement marks a potential breakthrough, a practical, scalable hydrogen engine tied to a trusted brand and a global vision. On the other, it's entering a landscape filled with obstacles: infrastructure, perception, and energy input challenges. Reverse electrolysis is clean, but it still requires energy to split water. If that energy comes from renewables, the system is beautifully sustainable. If not, it risks becoming another shell game, shifting emissions rather than eliminating them. The balance will depend on where governments, utilities, and innovators invest next. Still, Tesla has changed the game before. Electric cars were once laughed out of the room. Now they dominate headlines, sales charts, and climate policy. If Musk applies the same relentless execution to hydrogen, water engines could follow that same arc from curiosity to inevitability. The race is on. Between battery EVs, traditional hydrogen fuel cells, and now Tesla's reverse electrolysis model, the next decade will determine which path shapes our roads, skies, and cities. The winner won't just be cleaner, it will be faster, cheaper, and smarter. Musk is betting that the world is ready for the leap, that we no longer need to settle for compromises, that the cleanest fuel on Earth has been under our noses all along. And if he's right, the engine of the future won't roar, it'll breathe.